let's make a start. Now, if online people, if at any point I'm going faint or fuzzy, please let me know. I'm going to try and stand, that the mic is on its highest sensitivity, and I will try and like stand roughly in this vicinity. So see how it goes, but please do let me know. All right. Let's make a start. It's lovely to see you all. I think I've taught most of you at some point. Put your hand up if I've taught you before, probably in Comp 2511. Put your hand up if I haven't taught you before. It's lovely to meet you. We're going to have a fantastic term. Cool. So my name's Nick. For those of you who don't know me, I study software engineering here, and I teach a number of CSE courses. I've been mainly involved with the workshops for the past couple of years. So I'm kind of providing the course admin for this term and providing a lot of sort of technical oversight because as we've kind of talked about, you'll be doing some really interesting, cool technical stuff. And that kind of starts here today, where I'm going to go through the technology and the parts of the microservice ecosystem and what we mean when we talk about ecosystems generally. You've kind of got probably a vague idea already coming in. If you did, put your hand up if you did SENG 2021 with me last year. We did the e-invoicing stuff. Okay, put your hand up if you did SENG 21 before that. Okay, cool. So this course sort of follows on from last year's offering of SENG 2021 because we revamped that course last year, we're revamping this course this year. And in that sense, we're going to continue talking about microservices and sort of take that to the next level. I had another question, but I can't remember what it was. So that's okay. We'll crack on. Microservice ecosystem. So today, we're going to talk about, do a kind of quick recap of what we mean by service-oriented architecture and microservices as a concept. And we'll talk about lots of different paths there are to different microservice ecosystems. Okay, and as part of that, how do we define and design them? How do they communicate and interchange data? How do we manage our data model? How do we manage state? These are all really important questions to ask when you say, okay, well, here we're going to go build a microservice ecosystem, and you're like, cool, what does that mean? How do we manage that? And you're all probably used to from 153.125.11, right? You say, okay, you've got your front end repo, your back end repo, and your back end is one big monolith, right? Now we're kind of moving to a distributed world where we have a bunch of different services that all need to talk to one another, and that presents some really interesting challenges. I'm going to go through that today. So what do we need to consider? Lots of design considerations, a huge number of design considerations that come with this idea of let's split things up. And how do we keep things secure? Because security is important. So to begin with, I guess, you guys know what an ecosystem is generally, right? You've studied biology. You have animals and plants, and the animals feed off the plants, and the plants feed off each other, and you've got some commercial fishing going on here. There's all these different entities kind of interacting, and things kind of come and go. There's lots of stuff done asynchronously. There's stuff done synchronously in direct interactions. And when we talk about the idea of a microservice ecosystem, you can think of it as a sort of big metaphor for, or you could think of ecosystems generally as a metaphor for how microservices behave. Now, the next thing is I'm going to just talk about an ecosystem that we're using in this course. We're not working at this level of abstraction when it comes to building APIs, right? Like you've built APIs in the last course, you'll be building APIs in this course. But an ecosystem is just generally any piece of software that's interacting with other pieces of software. So in the case of the course, right, we have WebCMS, we have the course forum, we have SSO, which works via UNSW. We now have SSO for EdSTEM as of yesterday, which I'm thrilled about. We have our Atlassian toolchain with Confluence and Jira, and very soon that'll have SSO as well. We have GitHub, and that's integrated with Jira. You can link your tickets up to your GitHub PRs, and that's also linked to our AWS environment with auto deployments. On the teaching side, we use Google Sheets for marking. We use a class account, which lives on a physical CSE machine to manage marks and push them so that you can see them in WebCMS. The enrollments come from a UNSW system called NSS, and that is connected to the wider UNSW ecosystem. So can you kind of see there's all these moving parts or all these interactions, and everything is sort of one little service that does one tiny thing that contributes to a wider sort of group of organisms. All right, the next one is service-oriented computing. Now, I don't know how many of you this will apply to, but who here had Foxtel as a kid? Yeah? You all know what DVDs are, right? Like, you all remember DVDs. Yeah, cool. So, you know, DVDs, like, you used to have, who had a DVD store down the road from them? Or like a DVD rental place, and then they all shut down, right? So, you know, DVDs is media as a product, right? You go and buy your DVD and then it's yours. You can play it anytime you like. You know, it's going to live there forever and be watched like twice. And Foxtel was kind of interesting because it was the first exposure to this idea of, you know, let's have this service, right? Because well, probably your parents, right, pay a whole lot of money to have the Foxtel thing, and the person comes along and they install the cables because you need it to be connected to certain like switches in your house or whatever. And then you sort of pay as you go, right? Now, that's how kind of software used to work, in a way that it was software as a product. Another thing I remember from being a kid was when having like a Harry Potter and the Goblet of Fire game or something, right? And you'd like have your disc, sorry, what's the word? Your disc or your DVD that you put in your computer, and then you download it on your computer as well. And then you can run the game locally. Now, I'm sure most games still work like that. But the point is, software as a product moved towards software as a service. And that was really kind of started by Netflix when it came to streaming and media. And now, of course, we're in this age where there's 50 million different streaming services, and they're all competing with one another in this sort of streaming wars. And we'll talk about that in a second when we get to Netflix. But these ideas, this idea of software as a service instead of software as a product, is used at a bunch of different levels. And so we have three main ones that we talk about here. The first of those is infrastructure as a service. So back in the old days, when I say the old days, I kind of mean 10 years ago, which is pretty recently. Companies would say, and this is still the case in CSE in a lot of instances, is the companies would say, okay, we're going to have a data center or a server room, and all of our software lives in the server room. So you have these physical machines that are running 24/7, and the software is running on them, and they have to make sure that these machines are secure. They have to make sure they're ventilated, because the rooms get really hot, and you have to pay people to do all that. So it's very expensive. There's a lot of overhead. So the first step of service-oriented computing is say, well, let's outsource that. Instead of you having to maintain your own infrastructure, someone else does the infrastructure maintaining, and you pay, like Foxtel, a certain rate, every month to say, well, here's, a machine you can SSH into, and you can do whatever you like on that. You can host your software, you can build this platform, but the physical machines are somewhere else. The next layer of that is called platform as a service. Now, platform is a super vague term. Platform could mean an operating system, like when you SSH into your CSE account. That's kind of platform as a service, right? Because you're being given the operating system, the hardware's all living in K17, and you're coding your software on it. Platform as a service could also be literally an API, right? So you use someone else's API to build a front-end application, or you, like Pethy was talking about before, use someone else's API to build a wrapper API that does some more stuff. So platform, very, very loose term, but it kind of encapsulates everything between physical infrastructure and the last one, which is software as a service, which is everything that we use today. That's Google Docs, that's Netflix, that's Disney Plus, that's Confluence, Jira. And it's this idea of, okay, instead of paying, paying for a product, you pay per month. You pay for an individual service. So the hardware, the operating system, and the software are completely outsourced and accessed remotely. So when we talk about things being on the cloud, we talk about infrastructure, platform, and software as a service, where to some extent there's outsourcing going on. And that allows us to, instead of having to maintain, as I said, all the server rooms and the infrastructure ourselves, we can spend time leveraging off other people's code, their infrastructure, their machines, to do some more cool stuff and spend our money in interesting places. Okay, so that's service-oriented computing. Monolith versus microservice. I think George talks about this in his SENG2 lecture, and I think that's on tomorrow. You can probably go and crash that if you want to see George speak again, because he's awesome. But I'm going to go through the difference briefly now. I spoke with the uni a few months ago, and they said to me, oh, why doesn't CSE use Moodle? And I said to them, because Moodle tries to be this sort of one big service which rules them all, which can, solves everyone's problems. It's one massive centralized system. And as many of you are probably aware at this point, that kind of doesn't really work, because if you try to solve everyone's use cases, you end up solving no one's use cases. So the way to to deal with that, that's kind of become this trend in software architecture, is this idea of microservices, where instead of trying to do everything and do it poorly, you have a bunch of different services that do one thing well. And if you think back to our SENG3011 ecosystem, that's what this is, right? Confluence does your knowledge management well. Jira does project task tracking. AWS does deployment. GitHub does source and version control. Now, there's a trade-off with that, right? And every term in my experience, I read, oh, there's so many platforms and it's so annoying to, flick between them all the time, and there's lots of context switching, and that's a trade-off of the world we live in at the moment, where there's just lots and lots of microservices, right? Like think, the number of different websites you have to visit for one CSE course, or across UNSW, right? Like there's just tons of different products and services out there, because there's a lot of uniqueness to people's use cases. So that's a monolith versus a microservice approach. Now I'm going to go through a couple of case studies as to why, as a business, would you want to adopt microservices. And this is important because in industry, you have business people and they're thinking about KPIs and revenue and money and all the sort of thing that we as engineers kind of go, okay, cool, it kind of goes over our heads to an extent. And then we have the software engineers who are thinking about architecture, who are thinking about design practices, about programming. And there's a bridge to be built between the two. So if you can kind of understand, you're engineers, right? You can understand the engineering side. But if you can kind of understand why the engineering side matters to business people and how one influences the other, because they're kind of this symbiotic sort of pair of entities that need to work together. So if you can understand that, then it's really useful. So Netflix, that started the streaming wars. One of their big things was this idea of cloud shift, right? So you have your people who have, they say, well, we've got our software that lives on premises in our data center, and we pay all this money to have people, turn the lights on every day. They wanted to shift people from server to cloud, and this is happening in a bunch of places. I recently worked at Atlassian, where there's a huge shift at the moment to move big enterprise customers who are using Jira from server onto Jira Cloud. And as part of this movement into cloud, there's a move from a monolith approach to a microservice approach. And the reason for that is when you're on a server, you can have this massive machine and you can do what's called scaling vertically. I'm going to use my whiteboard markers now. So here's my instance of, let's say, Netflix. And when that's living in a big computer in someone's basement, you can say, okay, I'm just going to add more computing power. That works when you're not in the cloud. When you're in the cloud, that's kind of not how things work. So you need to do something called scaling horizontally instead, which says, well, instead of adding more individual compute power to the machine that I'm on, I'm going to say, well, here's my instance, and then I'm going to add more nodes. So we distribute things across a bunch of different nodes within maybe a single machine, or a series of virtual machines that work together on the cloud. And often you don't really have control over that because everything's outsourced in that sense. So they decided to move from monolith to microservices, and they started with their non-customer facing elements of their system all the way to customer facing elements. And you can see this diagram, which kind of shows different components of their migration to cloud over about, let's say, 2 years, which is very quick. And what they noticed as they started to go to cloud and to microservices was that their business started doing better. They started to develop more scalable software that allowed them to handle more and more users. And right, like think of the number of people that use Netflix at any one time, right? It's a lot of people. So they're handling over 2 billion daily API edge requests managed by over 500 cloud-hosted microservices. And by 2017, they had 700 microservices. And you can see that in this really cool picture here. This is all their microservices. Huge ecosystem. So it was this business decision. It wasn't just an engineering decision. And now, as a result, Netflix is a streaming giant. I don't know how well they're doing. I always read things that being like, oh, Netflix is not doing super well, but who knows? They stream all this content, as I say, put your hand up if you have a Netflix account. Yeah, awesome, everyone, cool, most people. Lots of subscribers, and this was the catalyst that started the streaming wars. The other thing they noticed was that compared to having their software stored locally in their basement, their costs were less, so that you save money by going cloud. All right, here's another case study. Very similar, Uber, which again sort of blew up in the early 2010s and is now, who uses Uber? Yep, I use it all the time because I'm lazy. Cool. So issues in business growth was related to monolithic architecture. So they had this monolith, right, which couldn't scale. It couldn't handle the number of users that were interacting with the software. When you deal with monoliths and legacy systems, there becomes a lot of inertia. Where you have one massive application and it takes longer for new engineers to understand the system just because there's so much code. There's more inertia, which is like resistance to changes. It takes longer to ship new features. There's more bugs and more risk in deployments. When I was at Atlassian, I worked on Jira, which is this monolith repo, and it was super interesting because the number of lines of code in Jira keeps going up, and the number of incidents and things going wrong was increasing exponentially. And that was because of the fact that there's this sort of gargantuan beast of a piece of software that just grows and grows in complexity to a point where it becomes very hard to manage. So that's, again, one of the trade-offs with monoliths and why people will move to microservices. Not scalable. So they just had a REST API, right, which is the same as what you built in your 1531 project. They had some adapters, they had a database like you would have done in 2021, but it was all contained within this monolith. Okay, so what they said is we're going to go to microservices, and what we'll do is we'll have one engineering team per microservice. So this team is responsible for building this service. This is a kind of a simplified version, but you can kind of understand they split up the domain into a series of different APIs. What that did was reduce coupling and dependency, and what it allowed them to do was say, well, I'm going to scale at this individual service level. Allow them to address bottlenecks. So rather than saying, okay, let's add more compute power to the entire monolith, they say, well, maybe it's actually just this one service that has a lot of load for some particular reason. So we'll scale that rather than having to scale everything, which saves money. Improve speed of development. The developers are happier. Things is just as simple as like when you're writing code, having to wait an hour for the continuous integration, right? Your pipeline to run because it's running all these tests on this massive monolith repo. If you go to microservice, that takes 3 minutes. Developers are happier, things get done more quickly. When we talk about influencing behavior in week 5, we'll talk about positive, immediate, and certain feedback loops. And that ties in very, very heavily with this. Overall quality, fault tolerance, the software was just better generally. What Uber realized they needed to do though was they had several hundred microservices all talking to each other. They needed to define some sort of global standard to say, well, how are these going to interoperate and how is this going to be compatible and how is that going to be the same across all our different services? And that's very similar to what we've done with the consistency of the event data set, which you'll see in the spec. Okay, that's our case study. So what I'd like you to do now is turn to the person next to you, and if you're not sitting next to someone, buddy up and introduce yourselves. And I'm going to give you about 3 minutes to think of Web CMS, which you've all been using, and figure out how you're going to split that up into different microservices. Make sense to everyone? Yep. Go. Got 3 minutes. You can use this Uber one as a sort of point of reference as well. Okay, I'll give you another 30 seconds. All right, cool. Let's call it there. Is anyone game enough to come up to the front and draw their microservices on the board? Yep. Let's do it, Luke. Catch. There you go.
All right. So originally, myself and Rohan were thinking we would split the lectures, like all the side tabs. So you got lecturers, staff, things like that kind of stuff. But then we also thought about the fact that there's different classes as well on WebCMS. Yep. So we thought maybe you've got like WebCMS itself, and then it can attach to a microservice that would return the information of each class.
Okay.
Like whatever.
Yep.
And then that would pull information from, a database that would clean and return the information on each thing. So lectures, staff, that kind of information.
Okay, cool. So you've got a microservice for each course. Is that what you're saying?
Yeah.
Okay. Cool. Thanks, Luke. Anyone else? Anyone? Doesn't have to be awesome, just has to be something. Any starting point is good. One person, please. I was going to bring Chopper Chops, but I ran out of time, so I'll do it tomorrow. But I will owe you a Chopper Chop in advance if you come and show your microservice architecture. Yeah, Peter, come on. Do yours in blue.
Thought about it a little differently.
Mm-hmm.
So you have WebCMS. So we thought about how lecturers and staff need accounts and students need accounts, so some sort of account management.
Yep.
Microservice. All accounts. Should have brought my laptop. Then obviously it needs to communicate with MyMSW or whatever it's like NSS or something.
Yep.
About enrollment data. So the right students and staff have access to the correct courses on WebCMS.
Mm-hmm.
Then you really should have brought my laptop. Yes, and from memory, tutors submit their marks on Google Sheets. I don't know where that goes, but then obviously the grades need to be displayed on WebCMS, so some way of showing grades.
Yep.
And then you've got like that stuff first, I guess. Content. You also got, I don't know if assessments are kind of displayed a little bit differently or not, but we can need to do assessments separately as well.
Yep.
That's about as far as we got.
Awesome. Thanks, Peter. Cheers. Cool. This is an open problem, and there's no like one right or wrong way to go about it. And most of the, I guess, knowledge about all this stuff has come from people in companies who've gone and done this. They say, okay, well, we're going to have our accounts microservice and our content microservice, and then they've gone and built it, and they've realized, oh no, this was the complete wrong way, or maybe it was the right way. So it's very empirical in that sense, and it's very hard because WebCMS might be completely different from the event intelligence system that we're going to be making, which is also different from the invoice system that we did last year. So each problem will have its own unique solution, and your task is to figure out the right tools for the job. And we're going to talk about some tools right now. When it comes to defining your microservices, we go with this principle that you're probably actually really familiar with called domain-driven design. Who here has taken Comp 2511? I would have expected most of you have at this point. Who here hasn't? Just curious. Okay, one person, two people. That's okay. That's fine. The knowledge in Comp 2511 will help you with this course. It's not a prerequisite, but you'll be able to leverage off what you've learnt there when it comes to designing your system. So domain-driven design is exactly what we do in Comp 2511 when we make UML diagrams. We say, okay, here's this problem space. What are the different entities? What are the attributes on each entity? How do these entities interact? What are the actions involved? You know, your methods in your Java classes, your classes as the entities themselves. If you've done databases, Comp 3311, it's the same thing with ER diagrams and this sort of data modeling. This is all part of domain-driven design where we model software to match a business domain. Conway's law, Conway was the guy who made the Game of Life. Google it if you don't know what that is. And he said this really interesting statement, which is that organizations who design systems are constrained to produce designs which are copies of the communication structure of those organizations. I'll leave that with you. Really important idea that we need to think about when we're defining our microservices, what is the bounded context? Because what's going to happen when you split up your services, you also split up the data associated between them. And probably one of the biggest problems in software design is a problem of what we call shared mutable state, which is state or information or data about a particular thing. And then you have multiple different processes or multiple different services, multiple different classes trying to sort of haggle over that state. In multi-threading in the world of parallel programming, that manifests as concurrency. But this can just be a general idea if you have a piece of data and there's coupling between two classes or between two services. So when we define the context of a microservice, it's important that we encapsulate as much relevant data as we can within the same service. So what I mean by that is here you can see that all the information about sales is in the sales microservice. This forms its own context, what we call a bounded context. And this dotted line is the boundary of that service. And as a result, it's the boundary of sort of a business process or a business element that's kind of self-contained. And this isn't immediately clear. You can also see that the customer and the product tables, classes, whatever you want to call them, entities, are actually shared between the sales context and the support context. So maybe you'd have, as a result, two different databases that both contain information about customers and products. How do you manage that? We'll talk about it. So when you're defining your microservices, make sure you do essentially a data model and then start to draw lines around what is this context. Okay, we have sales over here, we have support over here, and they kind of form their own sort of group of entities, and they can become a microservice. Okay, who thinks browsing and purchasing, are they separate contexts? I want you to close your eyes, think about it for 10 seconds, and if you think yes, put your hand up, keep your eyes closed. Who thinks yes? Keep your eyes closed, put your hands down. Who thinks no? Put your hand up. Put your hands down and open your eyes. Cool, all right. I get people to close their eyes so they don't get influenced by what other people are saying. One question you can ask, I'm not going to answer this by the way, but one thing you can think about as well, are they part of the same business process or a different process? So browsing and purchasing, where you think I'm going to go to Amazon or I'm going to go to Woolies, do an online order. I browse different products and then I'll purchase them. So is that part of the same workflow? Is that part of the same microservice? Is that part of the same context? And how much data do they share? Again, this comes back to coupling, because the more data that these processes share, the more they're going to have to send to each other. And that's really hard because we have to actually send it across a network. We'll talk about that. So define your bounded context. Go ahead. Okay, microservice design principles. This is what I just said about coupling, but you can kind of think of defining microservices as just being object-oriented programming on a larger scale. Instead of having, here's my class, here's my other class, or ER diagrams from databases, entities that interact. You want to apply the same ideas, but on the scale of groups of entities working together as services. So solid design principles, who knows what the solid principles are? Does anyone know S? Hand up. What does S stand for? Come on, sure you all remember. Not scalability. Come on. Starts with the word single. Yes, up the back. Single responsibility principle. What's your name? Joshua. Yes, that's correct. That's what we said before, right? Instead of being one service to rule them all, we have a bunch of services that each do one thing well. Okay, single responsibility. What's the next one? O. Yes, Ben. Open close principle. Should be open for extension, closed for modification. If I want to make changes, I shouldn't have to go and rewrite the entire thing. L. This one doesn't apply as much to microservices. Yeah, list off substitution principle. I. This one's a bit harder. Yeah, interface segregation. And D, which is a huge one, is dependency inversion principle. What is the dependency inversion principle? The dependency inversion principle says that we program to abstractions and not concretions. We program to, the principle is actually we program to an interface and not an implementation. That's how microservices work, because you have a bunch of APIs, application programming interfaces, that all talk to one another. Cool. As a result, we want low coupling and high cohesion. Minimal coupling, as I said, we don't want to rely on the implementation, we rely on an interface. And we should try and minimize dependency as much as possible. We'll look at that when it comes to choreography and orchestration in a second. The next thing we want is high cohesion. So as I said before, services form a bounded context and they are cohesive business processes. So, oh, okay. Yeah. Cool. So we'll cut this in a bit and then. We've got that to go. We've got a lot of stuff to go. Let's do choreography and orchestration, and then we'll finish up and let Greg do his spiel. Okay, so when we start, we've defined your microservices, and you're like, yep, cool, and have accounts and content, or we have 1511 and 2511 or whatever. How do you glue everything together? There's two main paradigms or design patterns when it comes to gluing microservices together. The first of those is called choreography, which is where you can think of it as like a dance class, right? So the services work independently, but they coordinate with one another. They use cues or events. So there's no kind of person there mediating or conducting everything, but they understand the sort of process to go through and what to look out for from the other services. Again, think of a dance. As a result, the method of control is determined by, as I said, a predefined process and a set of cues and events. Orchestration, it's like an orchestra, right? You have a bunch of players, they're all playing, and then there's one person who's the conductor, or one service, which is the orchestration or the conductor service, that's responsible for keeping everyone in time and managing the flow of information. Now, like anything in software architecture, it's a trade-off. You get good bits and you get bad bits about each one. So choreography, for example, we place an order to purchase a book. So the client goes through the API layer. That talks to an order microservice, an order placement service. That does its thing. Then it talks to the payment service. It sends it back to the order. Then the order goes to the inventory service. Inventory sends back to the order, and then it sends back to the user. So there's no one service that's kind of managing everything, but the services know what to look for, what to expect, and kind of follow the standards. That's not what I wanted. Choreography and orchestration. Now here we have a conductor service, which is called place order. So the client goes through the API layer and hits the conductor service, and then the conductor does everything. It talks to the order service, talks to inventory, talks to payment, and they don't talk to each other, as you can see. So what are the trade-offs? Well, choreography is good because it's loosely coupled. Now, in some ways, it's not loosely coupled because you have services that are reliant on one another in some way, as opposed to detached, like we saw in the orchestration diagram. But in some regard, they're loosely coupled. They're very easy to adapt, but it's harder to monitor the state of a process and see, well, where is a request going at any one point in time. Whereas if you are using orchestration, the conductor knows where the request is and what it's doing at any one point in time. So it's much easier to monitor. That's important. When we get to week 3, we'll talk about observability, which is understanding where your system is at and what it's doing. Orchestration, more tightly coupled, can be a single point of failure and more difficult to change. All right, we're gonna wrap it there for today. We'll finish off the rest of this stuff tomorrow, part 2, and Kathy will probably have some words to say as well. But are there any questions on anything we've talked about in lecture so far today? No, and I owe you a chop for tomorrow. Yeah, Luke.
Is there a specific language for this?
No, so you get to choose your tech stack, like we did with 2021, where you have to say, well, what are we going to write the front end in? What are we going to write the back end in? What are we going to do the database in? You do the exact same thing on the scale of your individual microservice. Good question. Yeah. Yes. What's your name? Sorry.
What else do you expect? Like how simple is it to say?
I think Bethy probably covered most of that stuff. The biggest change is the DevOps. So there'll be a lot more tooling and stuff where we're going to have this big AWS environment, and you're going to deploy your service into that environment. Whereas like last year in SENG2, you had to do the AWS stuff on your own. So there'll be a lot more integration, and there will be a lot more inter-team communication. Because this is the advanced software engineering course. You're not just working in your team anymore, you're one big company. And so you're going to actually have to talk to each other and try and get everything working in one big cohesive system. It's going to be a complete, I shouldn't use that word, it's going to be a complete mess, let's just say, but it'll be a good mess. We've got the course forum, we've got Confluence, we can talk to each other in person, which is lovely, and we'll figure it out.